All right, guys, we are now on to example number 4. It just seems that there's a never-ending list of examples, right? Yes, and that is because this is a physical chemistry topic. So there's a lot of variety of questions that they can ask you to calculate. So we're going to go through as many as possible, and hopefully that will cover the whole variety of questions that they possibly can ask you. Okay, so without further ado, let's look at the next homogeneous equation. So you have 0.5 moles of hydrogen and 0.5 moles of iodine mixed in a closed vessel, and the pressure is given as 2 atm. So at equilibrium, you're going to find that there is 0.1 mole of iodine found present. Okay, so putting down all this in the ice table, right? Because equilibrium concentration is not given for everything, so we will need to put it in the ice table. So basically the same sequence. Right at the start, we don't have a product, all right? And we note that the equilibrium concentration of iodine drops to 0.11. So there's a change of 0.39, negative 0.39. Okay, so because the mole ratio of the hydrogen is same as iodine, so we're going to get the same calculations there. So if the reactants, right, is minus 0.39, can you guess what is going to be the product based on the mole ratio? All right, 1:2. Okay, if you guess plus 0.78, you're absolutely right. That will be the amount of HI that is formed. So using all our values that we've calculated for equilibrium, we're simply going to plug it in after calculating, of course, the total amount of gas. All right, multiply by 2 atm. All right, just take the mole fraction here, multiply by the total pressure at 2 atm, and you'll get your partial pressure. Okay, so we're going to do the same for HI as well. Okay, so the partial pressure for H2 and I2, you only have to do it once because they are the same. They have the same mole ratio. All right. Okay, so after plugging in all of this, you will get the value of Kp as 50.3. Okay, so what if the question gives to us volume of gas? All right, so here we have this equation, and it told us that when 100 cm cube of NOBr was placed in a closed container, heated to constant temperature, it was found that your NO, right, has constituted 40%. All right, so very simply, you are going to know that your NO, right, is actually 40% in terms of volume. All right, so at the start, obviously, we are not going to have any of the products. And then since the change is plus X, due to the mole ratio of 2:1, you're going to have plus half X for Br2 to give you half X. Okay, so for NOBr, the change in volume is going to be the same as NO, but is negative. All right, so now that we've gotten the expression for all the equilibrium volume, we're going to just put it into expression here. Okay, because this is what the question had told us earlier on. Okay, NO constituted 40%. So volume of NO is simply your X over the whole thing. All right, so basically you just solve for X. This is more of a math question. You solve for X. X will be the volume of NO at equilibrium. Okay, so to get the total volume, you just need to calculate for the rest, okay, using the expression given. All right. So this should be quite straightforward for all of you.